How do the cyclic voltammetric results of the HCSBB-MEN and PBM electrodes compare in terms of their peak positions, polarization, and overall electrochemical performance? What insights can be drawn from the differences in the CV curves of these two materials, and what do they suggest about their potential for use in energy storage devices like sodium-ion batteries? What information can be extracted from the CV curves to assess the stability, efficiency, and reversibility of the redox reactions, and how do these factors contribute to the long-term performance of the electrodes? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the general behavior of bilayer capacitors as depicted in Figure 2.8, and how does it relate to voltage changes? How do bilayer capacitors discharge, and why does the voltage decrease linearly with time during this process? What distinguishes this behavior from that of batteries, and what specific characteristics of batteries prevent them from showing a similar discharge pattern? Why do batteries typically exhibit independent redox peaks, and how does this influence their voltage behavior during discharge? How do batteries maintain a constant voltage for a certain period during discharge, and what role does the specific potential play in this phenomenon? How does the pseudocapacitive behavior differ from the behaviors of both bilayer capacitors and batteries, and in what way is this intermediate between the two? What mechanisms mediate pseudocapacitive behavior, and how do these mechanisms influence the electrochemical properties of pseudocapacitive materials? What types of electrochemical properties are commonly found in pseudocapacitive materials, and how are these related to surface redox materials? Can you explain the role of surface redox materials like MnO2 in neutral, aqueous electrolytes, and how they contribute to the pseudocapacitive behavior of certain materials? What are embedded materials, and how do they function within pseudocapacitive materials such as Li+ embedded in organic systems or Mb2O5? What effect does the embedding of materials have on the overall electrochemical performance of the material? How do materials like T3C2 embedded in acidic, aqueous electrolytes exhibit broad and electrochemically reversible redox peaks, and how does this feature contribute to the pseudocapacitive properties? How do these embedded materials, through their electrochemical reversibility and broad redox peaks, bridge the gap between capacitive and battery-like behaviors, and why is this important for energy storage applications? What is the significance of pseudocapacitive behavior in explaining the process and kinetic mechanism of charge storage in electrode materials, and how does this behavior help us understand how charge is stored in these materials?